Allow me to start with a bit of an introduction of each of our guests. Kevin, I had the pleasure of touring one of your factories not long ago. Kevin has been involved in some very innovative production for the U.S. From batteries to other areas over a number of years. His factories are really fascinating. One of the reasons being Kevin started with high-end auto parts. And I'm not talking about for a Chevy. I'm talking about for McLaren's. I'm talking about Formula One, Indy 500. You can get one of his sports cars with a sticker price of $2 million, but you better bring an extra $1 million because you're not going to find it anywhere. You're going to need to spend $3 million. Kevin then, this is the ideal of commercial dual-purpose technology. He's transitioned to defense parts. So I welcome Kevin.
Thanks so much. Great being here.
Great. Peter. Peter is one of the founders of the new industrial corporation, the NIC. Maybe best to describe it as a merchant bank. A merchant bank has a, I would say, a special position in the world of finance. It's got sort of a wider and more agile remit often than other financial institutions. And in order to reindustrialize in the United States, we're going to need to have that kind of adaptability. So Peter, welcome aboard.
Well, thank you for having me.
Great. Maybe I'll start with you, Kevin. Why don't you just tell us what you're doing technologically and how it's different from older forms of manufacturing?
Well, I mean, the primary reason why you do not see investment in volume manufacturing in the West is that it is super capital intensive and design locked. So if you're going to build, say, a Cybertruck, you have to spend time engineering many different parts. You then have to engineer a casting mold or a stamping tool which can only build a single thing. And that casting tool or that stamping mold is super expensive and can only be amortized if you sell a very high volume. The same thing with the factory. The factory has fixturing for a single product. That's why when you have lower volumes, especially in something like defense, you don't see capital flow to those companies. So what our company focused on over a decade ago, and we've raised $1 billion in order to create and commercialize this system, was to fully digitize manufacturing. Not start with the current architecture using tooling of the product and fixturing of the factory, but to do completely toolless manufacturing and completely fixtureless assembly. And the way that that works is that we use AI to fully engineer the structure in days rather than months or years. We then have built our own printers. We'll be, by mid-year, building a printer a week inside our own factories. Those printers can print anything that's generated in the system, and then we design in, or the machine designs in, the assembly features. So we have a machine vision-based assembly system, robotic assembly system, and it's like the printer in that anything that gets generated or engineered on the system can be printed. Anything that is generated on the system can be assembled because the assembly features are in the parts. So this is full software-defined manufacturing. I'll give a quick example. Recently with Mach Industries, we got a set of requirements for a ground-launched, long-range effects cruise missile system. From whiteboard to successful flight was 71 days. That, once it was successfully tested, immediately could go into volume production. When we generate a structure, we don't generate it as a prototype, we generate it with its full volume manufacturing and assembly instructions. And I'd say that technology is now at a point where this year we'll be manufacturing several thousand affordable cruise missile systems using that system.
Several thousand.
Several
So
thousand.
not a couple dozen, several thousand. That really changes the equation. And what about the cost per unit? What can you tell us about how you're doing things versus more traditional manufacturing in terms of costs?
That cost is comprised of, when you look at, and we do the full structure. So what I'm talking about is full end-to-end, the body of the missile, the wings, the empennage, all of those are printed. We're taking what would normally be several hundred components and up to 100 different suppliers and reducing it down to 4 to 6 parts by printing in fuel tank, hydraulics, all of those other things. It makes it, lighter, increases fuel capacity. Those structures we are pricing at or below casting right now. So this is more cost effective today than casting is, while allowing for complete adaptability and much, much shorter development time and the ability to avoid any obsolete equipment. You simply have a machine, when something gets versioned, the same machine just has that data sent to it and it prints that new version and it assembles that new version. So this is literally faster, better, and cheaper and commercialized at volume today.
Yeah, I saw it. It's really stunning. Peter, why don't you tell us about the new industrial corporation? What are you trying to do? Why did you start it?
Yeah, so the New Industrial Corporation, we're an investment company that really sits at that intersection between venture capital and infrastructure project development. So one of the things that we saw in the market towards the reindustrialization goal is you have a lot of early stage companies that are highly capital intensive, and yet their financial ecosystem is the same. They're living off of the Sand Hill Road model, the Silicon Valley ecosystem that is incredibly well optimized if you are high OpEx, low CapEx. If you're a tech company, if you're software, it works well for you because it was built for you. If you are hard tech, if a lot of your company's value is ultimately going to be sitting in a physical built facility, it is not good. You end up having to raise greater and greater rounds. Your founders and your founding team get just crushed by the dilution. And because your valuation now has to be so high in order to underwrite that facility, you have very little margin for error. And that's not the way that any mature manufacturing company finances their facility. So our goal at the end of the day is to try to unlock lower capital, lower price capital for these companies. In the short term, what we do is we build their facilities off balance sheet. We are that infrastructure project developer. So in addition to a venture capital toehold investment, we also shepherd them along so that they can unlock the cheapest capital at every stage. They can maintain, lower dilution. They can have a reasonable valuation and ultimately get to market in a way that is best for their investors. And then, especially on the defense side of the house, that then also helps unlock lower cost for that end unit because they do not have to go back and pay the rates that they were paying on the financing side.
Thank you, Peter. I'm curious to know from your perspective, if you had to name 1 to 3 changes you'd like to see made in the Department of War to open things up, what would they be?
I mean, the first one is this kind of field of dreams dilemma with early stage companies. We have one company that we're working with that has a product that the DoW has expressed a tremendous amount of interest in, but they cannot actually sign a contract until they have that physical facility built to produce it. If they have that signed contract, financing that facility is a no-brainer. It's very simple. It's super easy. But falling in that gulf is, I think, one of those challenges. So number one, having a bit more certainty on the procurement side that could easily flow through to having creative financing arrangements. I mean, I think the idea of non-dilutive equity, that will convert at a discount to whatever the last round is, that is something that can make a tremendous amount of sense for these companies. But just being able to meet companies where they are is ultimately that challenge that I would love to see fixed.
Kevin, similar question. If you could change one or two or three policies in the Department of War, what would they be?
Well, first of all, I'd say fully digital engineering and manufacturing is something that needs to be qualified. Obviously, when you have something that is going to be deployed from air launch platform from an F-15, an F-16, and what's happened initially is we've accelerated that on some systems through foreign military sales, but creating not only with one of the branches of the military that formula for qualification for doing digital manufacturing with an additive manufacturing component, but doing that across the different military branches, making that clear, making it so that at the program level, you don't have someone taking on technical responsibility for a system without a clear qualification formula. That is now happening. So, that work is right now in play to turn what, we're in, I'd say the last year, foreign military sales of things, everything from affordable cruise missile systems to, I'd say, because it's public, the YF-21, we've done flight critical parts now on South Korean jet fighters. We did those initially to accelerate that qualification for military sales. Now moving that qualification in a clear way, that formula, that recipe across the different branches, first for unmanned and then manned aircraft, and then going back also and doing a qualification recipe for maintenance and sustainment parts. Because every single one of those machines that we have, in addition to being able to print any system generated on it, we can digitize almost any existing spare maintenance part or sustainment part, and the same machine can print those. Mm-hmm. So imagine your inventory is just digital inventory of parts where, as needed, they can be printed on any machine located anywhere. So I'd say that qualification formula that's clear across the branches that can be applied to legacy systems, new systems, and to sustainment is critical. And then the other thing is, obviously, we've seen lots of contracting officers leave the various branches, figuring out, and maybe the way is with some AI assistance, which you already see in the contracting in the commercial area, making that contracting process much quicker is, I think, also key.
Yeah, this is the power of software that I believe Divergent is tapping into, and we need to, as a society and country, to do that, and then we can really reverse the game globally with our competitors.
And if I can just double tap on the
Please,
foreign
Peter.
military sales aspect, that's also something where if DOW acquisitions are maybe taking too long, if it's going to be an uncertain lead time, being able to have some of that risk capital coming from abroad in the form of foreign direct investment that then flows into foreign military sales can very much help do an end run, create the stability for those companies in the short term, getting them to the point where they can fulfill larger contracts, but then also serving that critical need in the short term.
Peter, have you looked at the administration's America First arms transfer strategy?
Mm-hmm.
Tell us what you think of it.
Yeah, no, I think it's fitting in very closely on that point and helping ensure that we have a common picture, ensuring that they're unlocking those opportunities, getting the expedited approvals to be able to do that is fantastic. But I see the parallels between that, what the administration is doing in Project Volt on the critical minerals side of the house, and recognizing that we shouldn't have 15 different processes for 15 different allies, that we can speed things up in a dramatic way that both help build the capacity and the capability domestically, while ensuring that there's a very solid output for our allies who are now hitting those 3 to 5% of GDP targets.
Kevin, on the work you've done with our Korean allies, were there any particular obstacles that, from a governmental perspective, that had to be removed that were especially challenging?
I mean, we work with primes. So just to take a step back, we're a layer that is really the infrastructure layer for manufacturing, digital manufacturing, that goes across the entire defense industry. So we don't compete with anyone. I mean, think of us as Amazon Web Services, which obviously once you went from having to build your own data centers to just getting tools and being able to create software in the cloud and have it hosted in the cloud, you had tens of thousands of developers. We see ourselves, with the existing primes, new primes, doing that, like supporting that that total infrastructure. So, on those programs, we were working with a prime that was unable to find, in the first instance, any casting companies or its own capacity to be able to produce a number of different parts, like gearbox cases for landing gears of jet fighters. And I would say the foreign countries that we've worked with so far through the primes have very much welcomed the technology and the implementation of the technology.
What's the status of this kind of additive manufacturing that rests on a digital foundation? What's the status of that, let's say, in China compared to the US?
I would say China is, and I'll take a step back. When I first started working on this 10 years ago, it was to create that toolless and fixtureless platform. And additive manufacturing is good because you can generate a structure with an optimized geometry, and it can print that structure in a design agnostic way. The problem was all of these machines were designed not to be integrated into a system, or their requirements weren't driven by the requirements that system had to have for cost and speed. So, that's why we ended up designing and building our own printers as something that was integral to that overall system. And so we went away from the model of buy a printer from someone who's trying to sell a printer for every single purpose and trying to find an application. What that required was us literally going from probably the state-of-the-art printer was 50 grams per hour of output in an aluminum alloy to 700 to a kilogram, which is what we're or I'd say today we're doing, actually in our latest printer, 1 to 2 kilogram output per hour, right? So, something that was 20 to 40 x increase in output. I would say China is still using that machine approach. They haven't integrated anything into an overall digital system. They certainly don't have the digital assembly piece. But what they are doing is putting tens of billions of dollars into brute forcing, sometimes at big losses, having thousands of printing machines running all the time with, relative to what we're doing, much slower speed and, probably at some loss, but they're brute forcing it. So, and they're taking it into aerospace and defense in a big way. And so what our challenge really is to take this technology, which is really a leapfrog of their technology and their brute capacity and willingness to incinerate capital, by scaling it even when it loses money, is to be smart, adapt something which is better, faster, cheaper, and make sure that we scale that very quickly. The advantage of this kind of an adaptive system is it's a learning system. So as you're doubling capacity, the system's getting better and better and better. We absolutely need to do that now before the Chinese start to move from their brute force, many, many, many individual printers to a system level approach.
So what you're saying is we really have a productivity advantage right now if we seize it.
Yes, we have what I would say is an adaptive system advantage in that we have a learning system that is much more cost productive, is learning and iterating itself, and creates products that are better, faster, cheaper. And that in turn should create within that defense ecosystem an explosion of many new companies which can use the software and then have us print and assemble whatever they need to produce. It really creates fabless production companies. So you take an Apple on the chip side, if you look, it uses a set of Cadence tools, goes to TSMC, said, here's our design, stamp our chip. TSMC uses an ASML machine. Imagine that you've created a structure where that TSMC is distributed and we're building both the machines and the software for it. Right now, America has the opportunity to scale that way before anybody else and needs to take advantage of that opportunity.
Yeah, so this is much more than semiconductors, as vital as they are. This is a whole range of components that we've been suffering from shortages of capacity in our country.
Yeah, I mean, we're doing everything from full missile bodies, CCA fuselages, gearbox cases, maintenance and sustainment parts, warheads out of Inconel 718. We're doing, over 500 different products using the same machines to print and assemble them, back to back to back. So it is completely seamless manufacturing of any product out of any machine for printing and assembly. And that's what we need to start to think through. What is the strategic import of that? Yeah. And how do we roll that out?
Peter, why do entrepreneurs need help in project finance, in your experience?
I mean, to me, it's about leveling the playing field between the early stage companies that are just getting off the ground and the legacy incumbents who are in that space. I mean, number one, having a more competitive ecosystem. If you're able to level out that financial picture, that more competitive ecosystem will challenge the incumbents to do better, to not get complacent, to be innovating, to potentially acquire those early stage companies. But it'll also allow for the necessary churn to make sure that we're staying on top. I think that is the problem that we saw, post Last Supper dinner conversation back in the early 90s, where there was a strong trend towards consolidation. We're still in this process of being reliant on weaponry that's decades old, while we're seeing in firsthand, especially in the war in Ukraine, but also at the cutting edge of other conflicts, lead times or innovation cycles that are not measured in decades or years, but in days and weeks. So being able to collapse that down, I think, is going to be very important. A lot of that can go back to the primes, and they would be well positioned to use their ample research and development and kind of iterative manufacturing processes to get there. But there's also going to be plenty of opportunities for new companies to come up. The question is, are they going to be able to do that in a way and unlock the financing that will allow them to be competitive on their own right, and not just have it be a handful of companies that have sufficiently positive vibes that they can coast, or that they can overcome a massive challenge on just the capital financial side of the house.
I think you've written about there needs to be a Midwestern ethos that supplements some of the ethos that have been reigning in America for the last few decades. Would you describe that, share it with us?
I'm from Michigan. I think there's obviously a sense of practicality, frugality, but also an unwillingness to submit to the presumption that you lack agency. Or in other words, like, you can just do things. And I think this is a moment, and this is an administration, and this is a point in time globally where where the possibilities are boundless, they're endless, the upside is exponential. In some cases, like the war in Iran, the downside is also very significant, but making sure that we can have a well-calibrated sense of risk is going to be that difference. And I think if you look back at the prior panel, one of the panelists had Arthur Herman's Freedom's Forge in his lap. I mean, what the Midwest did to become the arsenal of democracy during World War II is something we should always keep in the back of our minds. It's not going to repeat. There'll be ways in which it rhymes, but making sure that we have the ability to scale up that capacity, and that we never give in to the potential to feel defeated, to feel like China's too far ahead, to feel like we cannot get back to where we were from a manufacturing prowess standpoint. It'll look different. It'll have a different mix on the employment side and on the kind of capital intensity side, but we can absolutely still have that within our possibility.
Thank you. Kevin, if someone wants to buy a part from China or buy it the way you make it, what's the cost differential? How much more do they have to pay for an American-made part?
Well, I mean, I would say on the defense side, obviously we don't want to buy parts from China, but I'll give an analogy on the automotive side. So, we build chassis structures for companies like Aston Martin and Bugatti, McLaren, Mercedes-AMG, Porsche, and ship them there. We are able to price better than whoever their casting suppliers are, but more important than that, we're taking something where, say on a system that's a suspension and braking system where you'd normally have a Brembo brake caliper and an upright, suspension upright, we print the caliper, the hydraulics are internal. They're not external lines with fasteners. There's not an attachment between the caliper to the upright. So we not only price that lower than those component parts together, but that structure is 30% stiffer and 40% lighter, and it's a single printed structure that then the brake pads and the rotor go in. It completely transforms the performance. What a company like Ferrari would say is, if somebody can do something that's 2.5–3% less mass, they've won. They've outcompeted Ferrari, much less 30–40% less mass.
So essentially, better product, cheaper. That's a formula to win. I want everyone in the audience to just take note. We have before us two patriots, people that went to the Ivy Leagues and chose to go into the U.S. military as enlisted. So as the expression goes, they know how to work. And very clearly right now, they don't have to be told, they're busy forging what's going to be our new national security industrial base. So thank you very much, Peter and Kevin Czinger.
Well, thank you, Jeff. Thanks so much.